All right, so the second example, we have a graph of a prime of t. So again, it represents a derivative. It's a rate of change. I remember it's in thousands of dollars per year, so that's the rate at which it's growing. For the total amount of donations received to a homeless shelter over 12 years. So again, this is the rate at which they're receiving more or fewer donations throughout the year. So either donations are going up, people are given more and more and more, or donations are going down. Doesn't mean this is what the donations are. Again, that's what the area accumulation is the difference of. All right, so over the 12 years, we have the following graph. All right, so again, for the first 4 years, from 2002, if I remember that's my starting year, there was a gain, right, in donations. Then there was a loss in donations. Then there was another gain, and then there was a loss, right? Area above is a gain. Area below is a loss. These would be my critical values, all right, and my endpoint. So 4 is a critical value, 8 is a critical value, 10 is a, and 12 is both the critical value and an endpoint, right? And then 0 is my endpoint, right? My domain goes from 0 to 12. So the first question is, the total amount of donations received for the shelter was increasing on the time intervals. What? Well, increasing means that's the area that is positive, right? The area above the x-axis or the t-axis. Well, it was positive over the interval 0 to 4, so over the interval 0 to 4. And again, over the interval 8 to 10, which means from the years, we do it in years, it's from 2002 to 2006, and also again from 2010 to 2012. All right, those are the years at which the donations were increasing, right? They were getting more donations than the previous year. All right, the next question, at what year, so I'm looking for the year, was the total amount of donations received for the city shelters at its lowest, so the absolute minimum. And so over the domain 0 to 12, I want to find the absolute minimum. So this is kind of a combination of some of the new stuff with the area of the curve, but also a throwback question to chapter 3. I want to find absolute on a closed interval. Well, absolute minimums on a closed interval either occur at the end points or the critical points. Well, since I want the minimum, the critical points that I want are just my relative minimums. I don't need the maximums. The maximums can't give me my absolute. All right, so I don't need to look at all my critical values. I just need to look at those critical values that are minimums and then my endpoints. Now I'm going to get started with the endpoints because I'm actually going to throw away one endpoint right away. All right, I've got this endpoint 0 here, but if you look at the graph, before that endpoint 0, the area over here was positive, right? There was a gain at that moment. So 0 is not going to be my minimum, all right? So 0 can't be the minimum because there's a gain coming up before it. 4 is a maximum. This is a relative max because I've got a gain before it. It's increasing, stopped, decreased, all right? Which means 8 is a relative minimum because I lost before it, right? It was moving down and then switched to moving up. This would be a max, a relative or local max. And then this endpoint would be a relative minimum, and it's also endpoint. So I would include 12. 12 would be a possible absolute minimum because it's both an endpoint and a minimum. And 4. So the two values I need to check, not 4, 8. 8 is the minimum. So the two values I would need to check are 8 and 12, right? 8 is a relative minimum. 12 is both a relative minimum and an endpoint, all right? The rest of them I don't need to worry about because they're maximums, right? 10 is a maximum, 4 is a maximum, and 1 is well above where I dip down, right? This is starting point is well above where I'm dipping in my previous answers. So my possible minimum, I have two possible places where I have a minimum. So possible absolute minimum are at time 8 and time 12. One of those, they're both minimums, one of them's the smallest minimum. And I have to figure that out by looking at the net change in my area. All right, so I'm going to look at the net change from 0 to 8 and compare it to the net change from 0 to 12. whichever of those is the smallest change in donations will be my minimum. And so remember, net change would be, well, I'm looking at the integration from 0 to 8 of my derivative, dt, that would be the net change there. And this one, I would look at the net change from 0 to 12 of my derivative. And whichever of those values comes out the smallest would give me my absolute minimum. And so remember, I add and subtract my area. So from 0 to 8, I'll go back up to my picture. So first we had a gain in donations, then we had a loss in donations. So it would be 85,000 minus 72,000. So it would be 85 minus 72, which comes out 13,000. Alright, so there was a net gain of $13,000 in donations. Right, the first 4 years they lost, the second 4 years they gained. Or the other way around. First 4 years they gained, the second 4 years they lost. But they had more gains in the first 4 than losses in the second 4. Alright, well then let's compare that to 12. So 12 will be, so again, I actually have the same two numbers, 85 minus 72. And then I have to add 25 and subtract 22. So add 25, subtract 22, and so just based on that, this is going to come out a slightly bigger number. Not a lot bigger, but slightly. It comes out 16,000 would be its net gain. And so they're both minimums. They would both be dips down in my donations. But 8 dips lower, right? There's only 13,000 net gain at that point versus a 16,000. So there's only a $3,000 difference. But that $3,000 means that 8 is the smallest. And so my absolute minimum happens at 8, which is 2010, right? Because it's 8 years after 2002. All right, so 2010 is the absolute smallest in this 12-year period. Again, what happened before and after, we don't know. But in this 12-year period, the donations dipped down to the lowest point in 2010. All right, next question. Which is larger, the total donations received in 2007 or 2009? Explain your answer. All right, so 2007 would be 5 years after 2002. 2009 would be, excuse me, 7 years after 2002. All right, so 5 and 7 was what I'm looking for, so I'm actually going to change my colors here. All right, so 5 puts me here. 7 puts me here. Now, I can't actually find the area because it cuts in the middle here. But if you look, this area between those two numbers, this would all be a loss, right? It's a negative area. And so at 5 years, I would have this 85 gain. I would have this little bit of loss here. But in 7 years, I would have this same gain, but I would have more loss, right? So that means 2009 would have fewer donations than 2007. And so, again, however you want to word that, so 2007 has more donations than 2009 because from 2007 to 2009, you are losing donations. Right? There's more negative, more loss area from 2002 to 2009, right? There's more negative area, so there'd be more loss over those years. And again, you could word that however you want, and the answer is 2007 is the larger amount, because you're losing more to 2009. How much did the total amount of donations received increase or decrease over the 12-year period? So now I'm looking at the entire thing. So we want to know this integration from 0 to 12 of my derivative. What's the net difference in my donations from 2002 to 2012? All right, so now I'm looking at the net change, which we actually found this earlier. So I'm just going to go and pull it from my earlier problem, right? That was what we did here. And so it came out 16,000. All right, this came out 16. Oops, I'll put 12. 16. Remember, it's 1,000. And so from 2002 to 2014, they had a total net increase of $16,000 in donations. Now, some years were increasing more, some years were increasing less, some years were decreasing. Over all of the gains and losses, right, over all of the years where we had gains and all of the years we had losses, when we finish over those 12-year period, we had more gains than losses. We had exactly $16,000 more gained than we did have in losses. All right, the last one's a hard one. Excuse me. But hopefully, once you see it done, you can kind of understand where it's coming from. All right, so suppose we know in 2006, the total amount of donations received to the city was $280,000. All right, what were the total donations received to the city shelters in 2012? And so what we know here is we're given an initial value. So again, this is an initial value problem. We know in 2006, which would be year 4, so the amount in year 4, remember everything's in thousands of dollars, so 280,000 would be how you'd write it, right? A4 would be 280,000, there, spit it out, right? What we want to find is the number of donations, 2012, which would be year 10. And so that's what we want to figure out. So this is an initial value problem. All right, I've been given an initial value. I also have given the graph of the derivative, and I want to figure out the total amount at 10. And so what you're going to do is you're going to use that net change, A10 minus A4, which I can find using my antiderivative from 4 to 10 of my rate of change function, right? I can solve that using areas. I know what A4 is, so I can plug that in, and so what's going to be left over is A10. All right, so A10 minus the 280 equals, well, I've got to figure this out. Well, that's when I'm going to answer. Biggest thing to remember here is I start at 4 and stop at 10, so it's just the areas between 4 and 10. So when I go look at my picture, I'm only going to add up the areas between 4 and 10. So I've got negative 72 and a positive. So this one's actually going to come out, this particular area sum is going to come out more negative because I've got more negative area than positive area. So negative 72 and positive 25, if I remember correctly when I get down here. Alright, so negative 72 plus positive 25. And so that comes out make sure I do it right. I'm going to get my calculator out. So negative 47, all right? So there was a net loss over those years from 4 to 10 of $47,000 in donations. But it started out with 2,080, and so I add the I keep saying 280 to the other side. And so a 10 equals 233. And so that means, we'll put AA, by 2012, they had 233,000 in donations. All right, that's how much donations there were at the end, or by 2012, right? 2012, make sure I write the right time down, yes, 2012. All right, so again, they went from 280,000 to 233,000. My brain's a little mush today. All right, so there's the second example of if we're given the graph of the derivative, and we know the area sums underneath the graph, and using that to answer questions. All right, and so that's the last example of that. The next examples will be ones where you can solve them by hand or on the calculator. We'll be given derivatives, and we'll get to that in the next videos.